What if the greatest mysteries of our age aren't hidden, but simply ignored? In the stillness of night, a low hum presses against the silence. It creeps into bedrooms, vibrates through walls, and unsettles the thoughts of those who hear it. They describe it as a distant diesel engine, ever-present, unrelenting. Some go mad trying to escape it. Others move across oceans only to find it waiting for them again. This is not fiction. It's a sound that can be recorded on instruments, detected by seismographs, and measured in frequencies between 30 and 80 hertz. And yet, if you ask most scientists about it, they'll offer little more than a shrug. Official investigations stall, research proposals vanish. The data, when it exists, is buried. Across New Mexico, Ontario, Australia, and more than 100 other places, people describe the same sound. It began, at least in the modern sense, in Bristol, England, in the late 1960s. Since then, the reports have grown, but oddly, not the understanding. Only a small fraction of the population can hear it, but for those who can, it changes everything. Sleep disappears. Concentration fractures. In extreme cases, so does the will to live. Scientists have measured it. In 2012, a team captured it using acoustic instruments and confirmed it had no apparent environmental source. Governments acknowledged low-frequency anomalies. Theories circulated: electromagnetic interference, military transmissions, distant industrial machinery. Yet none fully accounted for the sound's reach or its bizarre consistency across locations and years. And then, just as researchers neared answers, silence, not from the hum, but from the institutions tasked with understanding it. In one case, a government-hired acoustic team was abruptly ordered to halt. Their findings were classified, records destroyed. Researchers instructed to forget what they had uncovered. For the sufferers, this is no metaphor. It's an invisible affliction, dismissed as delusion, misdiagnosed as mental illness. Yet symptoms vanish when they leave affected zones. Multiple people hear it simultaneously. The hum can be recorded, and still funding is denied. Studies are suppressed. Journal articles are quietly excluded. One researcher who pursued the hum for a decade found himself facing more than scientific resistance. Equipment began to fail. Data disappeared. When he finally traced the sound to what he believed was a specific industrial source, officials visited him. They did not threaten, not overtly, but they made it clear publishing his findings was unwise. Meanwhile, new towns fall under the hum's spell. Its presence grows, map by map, life by life. And yet, the world's most powerful institutions in science offer no answer, and more disturbingly, no desire to seek one. So, what does it mean when something measurable, reproducible, and destructive is ignored by those meant to explain it? What does it say about the boundaries of our curiosity, or perhaps the limits of what we're allowed to understand? The hum continues, and with it a question echoes louder than the sound itself. If science refuses to listen, who will? It begins with a flicker. A quiet Norwegian valley, sparsely populated and surrounded by pine-covered hills, becomes a stage for something the world has no language for. In the darkness, lights rise, not lightning, not aircraft. They hover, glide, twist, bright orbs changing shape and color as if responding to the watchers below. The people of Hessdalen have seen them for generations. But in the 1980s, the sky over the valley lit up with such frequency that ignoring them became impossible. At times they appeared 20 times a week, white, red, yellow, and orange lights that floated silently, then burst into movement at impossible speeds. This wasn't folklore. It wasn't whispered mythology. Scientists came. They brought radar, cameras, magnetometers, spectrum analyzers. They installed permanent equipment. The results were undeniable. Objects moved faster than any known aircraft, changed direction without inertia, and left electromagnetic signatures behind. Radar confirmed them as solid. Eyes saw only light. One event in 2007 revealed something stranger still. As researchers recorded, their equipment failed. A car engine stalled, a watch stopped, and restarted when the light vanished. It was as if something had passed through that warped the rules. And yet, the more data appeared, the less support came. Funding applications were denied. Scientific journals declined to publish. The lights were declared unworthy of study, despite thousands of hours of footage, measurements, and observations. Even more unsettling were reports of the lights interacting with people. Observers who waved at them saw them approach. Researchers arriving at their observation points often found the lights already there, waiting, watching. Some vehicles were followed for miles. As if the lights were aware, scientists who dared present the data faced professional exile. Grants disappeared. Their work labeled pseudoscience. One leading researcher was investigated by his own university, not for falsifying data, but for studying something too strange. And so the lights continue. The station still records them. People still see them. But no major institution will touch the phenomenon. A reality that has unfolded for over a century, captured on tape, logged by instruments, exists in a limbo between what we know and what we're willing to believe. Why? Why does the scientific world turn away from the most well-documented aerial phenomenon outside of aviation? Why do reproducible results invite ridicule instead of curiosity? Perhaps the greatest discomfort lies not in what the lights are, but in what they imply. That we are being watched, that our understanding of the physical world may be incomplete, that something intelligent might share this sky with us, not from stars far away, but from just beyond our perception. The lights over Hestdalen remain, unexplained, unwelcome in mainstream science, not because they aren't real, but because they are. And so we ask, what else is waiting just above the tree line if only we dared to look up and believe our own eyes? It started as a sound. In 1997, deep in the Pacific Ocean, underwater microphones designed to track submarines picked up something unexpected, a massive, low-frequency noise unlike anything ever recorded. It was quickly nicknamed the Bloop. The sound didn't just echo. It roared across thousands of miles, detected simultaneously by sensors more than 3,000 miles apart. Its profile hinted at something biological, organic. But to produce a sound that loud, the source would have to be several times larger than a blue whale, the largest known animal on Earth. At first, excitement rippled through the scientific community. A new species? A glimpse into the deepest, least explored regions of our planet? Then, just as suddenly, the conversation stopped. The recordings were classified, research halted. Scientists with access to the original data found their permissions revoked. And when the public pressed for answers, an official explanation emerged. Icequakes, glaciers cracking near Antarctica. A convenient theory, but a problematic one. Icequakes don't sound like that. Their acoustic signatures are jagged, abrupt, not fluid and resonant like the Bloop. More troubling still, the epicenter of the sound wasn't near any glacier. It was over 1,500 kilometers from the nearest ice shelf. Privately, marine acousticians disagreed with the icequake theory. They said so softly, off the record. But their analyses never reached peer-reviewed journals. Their objections were never included in official reports. The Bloop wasn't alone. Over the years, hydrophones captured similar unexplained underwater sounds, each with acoustic markers that hinted at massive, moving sources. And each time, the data followed the same pattern, reviewed, flagged, then quietly archived beyond reach. One longtime researcher described a recurring phenomenon. When the sensors picked up sounds that defied classification, the data would vanish into restricted files. Not lost, just removed from science. And what remains is a silence more mysterious than the sound itself. The ocean is vast, covering over 70% of our planet, most of it unexplored. It's entirely plausible that life exists in its depths that we haven't imagined, that something ancient or alien in nature swims beneath us, breaking the silence once in a generation. But instead of investigating, we dismiss. Instead of exploring, we explain away. Why? Is it fear? Or something more pragmatic? A quiet decision that some discoveries are best left unconfirmed. The bloop was heard just once, but its echo lingers. In the absence of research, in the quiet closure of inquiry, and in the possibility that beneath the waves something unknown called out, and we chose not to answer. It was just a blip on a screen, a spike of energy lasting less than a blink. But what it carried changed everything. In 2007, astronomers analyzing radio telescope data stumbled upon something entirely unexpected, a millisecond-long burst of radio energy from deep space, stronger than anything they'd seen before. It came from far beyond our galaxy, and yet arrived with astonishing clarity. They called it a fast radio burst. At first, it seemed like an isolated anomaly, but more appeared, dozens, then hundreds. Bursts from galaxies billions of light-years away, each releasing as much energy in a fraction of a second as our sun does in a day. The signals weren't random. Some repeated from the exact same coordinates, again and again. Some carried patterns that looked eerily like information. One even appeared to echo its own signal, as though something was transmitting, pausing, then transmitting again. The deeper astronomers looked, the stranger it became. In 2012, one team noticed that many FRBs had passed through space as though guided by a single path, the same precise conditions over billions of light-years. The odds of that happening naturally? Less than 1 in 10 million. Some researchers quietly raised the possibility of artificial origin, a beacon, a transmission. Perhaps not meant for us, but intercepted by accident. Then came the suppression. Papers suggesting intelligent origin were rejected. Proposals to study FRBs lost funding. One observatory, after detecting a signal with a complex repeated modulation, something that bore the hallmarks of encoding, had its program shut down. Budget reasons, they said. Meanwhile, military officials began taking an interest. In 2019, one team reported unannounced visits by officials asking detailed questions about detection methods. The observatory's funding was pulled shortly after, despite having just received a grant. Today, thousands of FRBs have been cataloged. Their nature remains unexplained. Their origin? Largely ignored by mainstream science. What do we do when the sky speaks in a language we don't understand? What if we're overhearing a conversation not meant for us, or one we're too late to join? Science demands skepticism, but in this case, it seems to have chosen silence instead. Not because the signals lack evidence, but because they carry a weight that threatens what we think we know. The universe may be speaking. The question is, do we dare to listen? It drifts silently through the air, a glowing sphere pulsing with light, moving as if alive. For centuries, people have described the same vision, orbs of fire appearing during thunderstorms, floating through walls, dancing down corridors, sometimes vanishing without a trace, other times exploding with a force that scars the landscape. They call it ball lightning. Most scientists still call it myth. Yet the phenomenon has been recorded thousands of times by pilots, soldiers, meteorologists, even physicists. Photographs exist. Videos exist. In 2006, Chinese researchers recreated it in a lab. In 2012, they recorded its natural spectrum using scientific instruments. Still, mainstream physics looks away, because what ball lightning suggests doesn't make sense. These glowing spheres defy the known rules of plasma physics. They maintain coherent form far longer than any natural plasma should. They pass through solid matter. Some are hot enough to melt metal. Others leave no trace. And yet, despite all this, the reaction from the scientific establishment has been cold. Research proposals vanish. Follow-up studies are denied. The successful Chinese experiments? Published in journals, then quietly forgotten. But not everyone ignored them. Declassified documents from the Cold War reveal intense military interest. The potential for weaponry, for energy storage, for propulsion, it all hinted at breakthroughs far beyond conventional science. Programs were started, then classified, results locked away. What's most puzzling isn't the mystery, it's the resistance to understanding it. Ball lightning, if harnessed, could transform physics. And yet, the very institutions that should be racing to study it have instead sidelined it. Perhaps because it doesn't fit. Its existence breaks the boundaries of accepted theory. Its behavior suggests forces we don't yet grasp. And in the halls of science, anomaly can be heresy. But the reports keep coming. From farms and factories, from airline cockpits and military bases. The spheres appear and vanish. Their presence as undeniable as it is unwelcome. What does it mean when nature shows us something extraordinary, and we choose not to look? Perhaps the most illuminating thing about ball lightning isn't the light itself, but the shadow it casts over the way we choose which mysteries are worthy of our attention. In a quiet Canadian workshop in 1979, something impossible happened. A piece of metal lifted off a table, unaided, unsupported, and without warning. Moments later, other objects began to move. Then, before stunned witnesses, dissimilar materials began to fuse together. Wood into copper, aluminum into steel, all at room temperature. The man behind the experiments was not a magician. He was an engineer experimenting with high-voltage electromagnetic fields, Tesla coils, and signal generators. What he stumbled upon would become known, unofficially, as the Hutchison effect. It was real, filmed from multiple angles, watched by scientists, journalists, and even military observers. Cannonballs floated, wooden blocks shattered midair, metal bars twisted, melted, and fused without heat. And then, silence. Instead of launching a revolution in physics, the response was suppression. His lab was raided, equipment seized, experiments sabotaged. Attempts to replicate the effect in academic settings failed, but under strange circumstances. Missing components, power surges, equipment inexplicably failing at crucial moments. Publicly, the phenomenon was dismissed. A hoax, they said. A trick. But the videos remained. The materials remained. And most curiously, the interest from government agencies never disappeared. If it were mere illusion, why confiscate the equipment? Why monitor the researcher? Why interfere with replication attempts? Some scientists did examine the fused materials. What they found defied explanation. Crystal structures that don't occur naturally, bonds that shouldn't form outside of extreme pressure and heat. Yet the findings were buried. Journals declined to publish. Funding vanished. The effect, whatever it was, violated core assumptions about matter and energy. And in the face of that challenge, the scientific establishment chose not to adapt, but to deny. The man behind the Hutchison effect never claimed to understand it fully. He only knew what he saw and what his instruments captured. But knowledge that disrupts established laws rarely finds welcome. So the footage remains, bizarre, unexplainable, authentic. A window into a reality science has decided not to acknowledge. And we're left to ask, when the impossible is seen, measured, and still ignored, what does that say about the boundaries of belief? And who gets to define them? In the subtropical heat of southern Florida stands a monument not to industry, but to mystery. It's called Coral Castle, a complex of massive stone blocks, some weighing more than 30 tons, carved and arranged with uncanny precision. Walls, obelisks, perfectly balanced gates, all created by one man. Alone. At night. Without modern tools. His name was Edward Leeds Kalnin. Barely 5 feet tall, weighing just over 100 pounds, he claimed to know the secrets of the ancient Egyptians, how they built the pyramids. He left behind no blueprints, no machines, just a legacy that seems to defy physics. Visitors can walk through Coral Castle today and see the mystery for themselves. A 9-ton gate once rotated with a finger's push. Blocks so precisely fitted that no mortar was needed. Stones stacked vertically, balanced on pivot points with tolerances still difficult to achieve with modern machinery. Engineers have tried to explain how he did it. Some speculate levers and pulleys. Others propose cranes. But no such equipment was ever found on the site. Even using teams of workers replicating what he achieved remains difficult. And Leeds Kalnin, he worked alone at night unseen. Neighbors recalled strange humming sounds during construction, but never saw machinery. Some say he used magnetism. Others suggest acoustic resonance. But the truth is, no one knows. After his death in 1951, tools were found. Simple chains, tripods, a mysterious flywheel, none capable of the feats he accomplished. A notebook was rumored to exist, detailing his methods, but it was never recovered. Coral Castle is often treated as a roadside curiosity, a tourist attraction. But engineers who study it walk away troubled. They say what's there shouldn't be possible with the means available. That achieving such balance, such precision, requires knowledge we can't easily explain. And still, no major scientific body has investigated the site. No archaeological institutions have pursued serious study. University departments avoid the subject. Proposals to explore the mechanics are rejected. Why? Is it because it's easier to dismiss than to admit that one man with limited means might have discovered a principle we've forgotten or never knew? Coral Castle stands not just as a mystery of stone, but as a question etched in silence. What if our understanding of the physical world is incomplete, and the answers are hiding in plain sight, carved into coral by a man who asked for no recognition, only the chance to build what no one believed possible? The room is untouched. A quiet corner of a modest home, curtains undisturbed, furniture intact. But in the center of it all, a body is gone, reduced to ash, bones calcified, organs vaporized. And yet the armchair remains, barely scorched, no flames spread to the walls, no smoke damage up the ceiling. This is the haunting signature of spontaneous human combustion. For centuries, scattered across history, there have been reports of bodies consumed by fire from within. Fires so intense they rival industrial cremation, yet somehow remain confined to the person alone. Often only a leg or foot is left behind. The rest vanished in heat. In 1951, one of the most well-documented cases occurred. A woman was found reduced to ash in her apartment. Her body had burned completely, except for one lower leg. The chair she sat in was largely intact. The room showed heat damage only at waist height. No accelerants were found, no signs of forced ignition, no explanation that fit the physics of fire. More cases followed. In 1982, firefighters broke into a home after seeing blue flames through a window. A woman lay inside, nearly vaporized, yet the nearby curtains were untouched. The temperature required to incinerate bone exceeds 1,600 degrees Fahrenheit. But such fires should consume everything around them. These didn't. Some researchers proposed the wick effect, the idea that clothing acts like a candle wick, burning body fat slowly over hours. But controlled experiments failed to reproduce the localized intensity or speed of actual cases. Even under ideal lab conditions, the wick theory couldn't account for the results. The pattern is consistent. Victims often show signs of internal burning. Witnesses describe strange colored flames, blue or yellow, oddly self-contained. The fires radiate intense heat, and then nothing. No smoke alarms triggered, no structural fires started, just ash, confusion, and silence. Fire investigators, off the record, admit these cases defy logic. Yet attempts to study spontaneous human combustion are dismissed out of hand. Research proposals go unfunded. Fire science departments avoid the topic entirely. Why? Perhaps because the implications are too unsettling, that the human body could ignite from within, that there might be mechanisms we don't yet understand, that under the right or wrong conditions, something hidden deep within us can turn catastrophic. But ignoring it doesn't make it disappear. Cases continue to surface, still rare, still inexplicable, and still treated as if they never happened. What does it mean when the human body becomes a mystery to the very science that claims to understand it? And what else lies dormant within us, waiting to ignite? It was supposed to be a routine sonar scan. In 2011, a team of ocean explorers surveying the floor of the Baltic Sea came across something unexpected, a massive circular structure resting 300 feet below the surface. Nearly 200 feet across, it was symmetrical, unnaturally smooth, and unlike any known geological formation. They called it the Baltic Sea Anomaly. At first glance, it resembled a disk, with straight edges, angular cuts, and what looked like a staircase leading into its side. A trail extended behind it, over 1,000 feet long, as if something had skidded to a halt on the ocean floor. The team returned with cameras. What they saw added to the mystery: internal chambers, passage-like structures, and electromagnetic disturbances. Equipment malfunctioned in its presence. Satellite phones stopped working. Electronic devices failed. Once the divers moved away, everything returned to normal. Samples were brought to the surface. Some showed signs of extreme heat exposure, over 1,000 degrees Fahrenheit. Others contained traces of metals rarely found at that depth. Carbon dating was impossible. The isotopes didn't align. Mainstream science was unimpressed. Geologists dismissed it as a natural rock formation, glacial debris, they said, despite the geometric patterns, despite the strange material composition, despite the electrical anomalies. The explanations didn't match the data, but the scientific world had already moved on. The team that discovered it sought help. Universities declined. Private investors withdrew. Research permits were delayed, then denied. Entire regions of the site were declared off-limits for environmental reasons, even though it lay far below typical ecological concern zone. One potential sponsor reported receiving unexpected government calls, advising against further involvement. To this day, no large-scale excavation has been allowed. The structure remains unexplored, cloaked in bureaucracy and silence. An anomaly not only in shape, but in the reaction it provoked. What lies beneath the Baltic Sea may be a relic, a natural marvel, or something far older than our history dares to imagine. But until it's truly studied, it remains a question unanswered. And perhaps that's the point. In a world where answers often lead to more questions, and sometimes uncomfortable truths, it's easier to label mystery as illusion, to file it under unexplained and move on. But the sea does not forget. It keeps its secrets patient and vast. And one of them still waits, resting in the silt, humming with silent energy beneath a curtain of willful ignorance. It lasted only 72 seconds, but it changed the course of a search that had spanned decades. On a warm August night in 1977, a radio telescope in Ohio known as the Big Ear recorded a signal from space. Not just any signal, a narrow-band radio transmission exactly at 1420 measurable, the hydrogen line, the frequency many believed an alien civilization would use to communicate. It was powerful. It was clean. And it matched every theoretical prediction of what an artificial extraterrestrial message might look like. When the astronomer reviewing the data saw it, he circled the numbers and scrawled one word in the margin: "Wow!" The name stuck. The mystery did too. The wow signal never repeated. Despite years of pointing radio telescopes at the same patch of sky, in the constellation Sagittarius, far from known stars, nothing ever came again. Yet no natural explanation fit. It wasn't a comet, it wasn't a satellite. The frequency was too precise, the duration too perfect, the shape of the signal too intentional. Still, science moved on. At first, the signal ignited excitement. Astronomers debated its origin. SETI programs received a surge of interest, but over time, attention faded. No follow-up signal meant no proof, and without proof, the search faltered. In 2017, a new theory was proposed, that the signal came from a passing comet. It was widely publicized as a solution, despite immediate criticism. Comets don't emit narrowband signals at that frequency. Their emissions are diffuse, scattered, and inconsistent with what the Big Ear detected. But the narrative stuck. Mystery solved. Interest closed. Behind the scenes, attempts to investigate further were quietly blocked. Proposals for dedicated telescope time were denied. Scientists who pursued the case too closely found their work labeled fringe. Then came the final insult. The Big Ear telescope itself was dismantled in 1998. The one instrument that had detected the most promising signal in the history of the search for extraterrestrial intelligence was torn down and paved over. No dedicated effort was made to monitor the signal's origin. No mission was mounted to revisit it with modern tools. The wow signal remains the closest we've come to hearing something from beyond. And yet, instead of opening doors, it seems to have closed them. Why? Perhaps because the signal said more than we were ready to hear, that we are not alone, that someone or something once whispered across the stars and we heard it, briefly, and chose not to answer. In a world defined by measurement, documentation, and peer review, one pattern repeats with uncanny precision. The more a phenomenon challenges what we think we know, the less willing we are to study it. 10 mysteries, scattered across oceans, skies, laboratories, and quiet corners of the Earth, all share something deeper than unexplained data. They share neglect, suppression, silence. These are not ghost stories. These are real, observable, measurable phenomena. Recorded on instruments. Witnessed by professionals. Captured in data that was then ignored. The hum that haunts towns and cities worldwide. Recorded, yet denied. The lights over Hestdalen, documented with scientific rigor, yet dismissed as fantasy. The Bloop, echoing through the Pacific with a voice that didn't belong to any known creature, reclassified, then forgotten. Radio bursts from the edge of the cosmos, bearing the marks of encoded intelligence, quietly shelved. Ball lightning, recreated in labs, seen by pilots and physicists alike, treated as too rare to matter. Levitating metals, fused materials, and energy anomalies that violate physics, explained away, though never explained. A castle of coral, moved and placed by one man with no machines, visited by tourists but not by scientists. Bodies burned into ash, while furniture remained untouched, catalogued, then ignored. A perfect disk at the bottom of the Baltic Sea, bristling with electromagnetic strangeness, blocked from investigation. And a 72-second signal from the stars, matching every model of extraterrestrial transmission, heard once and then never again. Each of these moments is more than an outlier. Each is a mirror, reflecting the boundaries of curiosity. What science chooses to see and what it chooses to avoid. It's not the lack of data that keeps these mysteries in the shadows. It's discomfort. Institutional inertia. The cost of admitting that some pieces don't fit the puzzle, and might never. But mystery is not the enemy of science. It's the spark. And yet, again and again, when faced with the unknown, the response has not been to lean in, but to look away. Why? Perhaps because the cost of rewriting what we know is greater than the comfort of ignorance. Or perhaps because some truths, once uncovered, demand more from us than we're ready to give. These phenomena remain, persistent, real, waiting, not for belief, but for the courage to ask the questions we've been told not to ask. Imagine a room filled with questions, each more unsettling than the last, and every one of them unanswered, not because they can't be answered, but because no one is officially allowed to try. Across these 10 phenomena runs a current stronger than any magnetic field, deeper than any sonar reading: suppression. Not the suppression of ghosts or folklore, but of hard data, peer-reviewed studies, physical evidence. Not of wild theories, but of simple inquiry. Each time the pattern repeats. Initial discovery brings interest. Investigators gather instruments, funding, and collaborators. Measurements confirm anomalies. Results defy conventional explanation. And then, the funding dries up. The studies are canceled. Access is revoked. Papers vanish before publication. Equipment malfunctions at critical moments. Researchers are warned, softly, indirectly, but unmistakably, to move on. This isn't a conspiracy in the theatrical sense. It's something quieter. Institutional resistance, the invisible scaffolding of what science chooses to call serious, and what it labels nonsense. To challenge dominant theories, especially in physics or cosmology, is to risk reputation, funding, career. No matter how solid the data, if it doesn't fit the framework, it is treated as noise. Even when the evidence is overwhelming. Even when it is captured on film, etched in sonar, recorded by radar, witnessed by dozens. The hum that breaks minds, the lights that seem to think, the sounds from beneath the sea and above the stars, the fire that consumes without spreading, the signal that whispered across space, and the gatekeepers look away. Not because they don't believe, but because belief is irrelevant in the machinery of modern science. What matters is publishability, fundability, conformity. The result? A world where the edges are left unexplored, where the deepest mysteries are locked not behind vaults, but behind indifference. And yet the phenomena persist. In the sky, in the ocean, in the soil, in the quiet moments when reality bends, and no one is watching. Perhaps the greatest mystery is not what we've found, but what we've chosen to forget. There's a quiet tragedy woven through these stories, not in the phenomena themselves, but in the silence that follows them. Each of these mysteries began with awe, a strange light, a sound from the deep, a burst of radio energy from beyond the stars. Each invited us to ask, to seek, to wonder. And then, to retreat. What changed? Not the phenomena. They continued. They still continue. What changed was us, or rather the institutions built around the idea of knowing. Somewhere along the way, the mandate to explore gave way to the comfort of certainty, and anything that threatened that certainty was pushed to the margins. But knowledge doesn't grow in the center. It grows at the edges. That's where these stories live, at the edges of sound and light, at the thresholds of matter and energy, at the boundaries between explanation and mystery, and maybe that's why they frighten us, because they remind us that the world isn't finished, that reality is still being written, that the map of what we know is surrounded by oceans of what we don't. Science, at its best, is a way to navigate those oceans. But lately, it seems we've become more interested in redrawing the borders than in setting sail. So the lights in Norway flicker on, unseen by the journals. The bloop echoes in the deep unstudied. The hum drives people to despair, unacknowledged. And the signal from the stars, once our most promising sign of company in the cosmos, sits in a file, unsolved and unsearched for. We've become curators of certainty instead of explorers of the unknown. But it doesn't have to stay that way. Wonder is still available to us. Curiosity has not expired. The skies are still full of questions. The earth still hums, the stars still whisper. The door to discovery is not locked. We've just stopped knocking. So, what remains after all the signals fade, the lights vanish, and the questions are left unanswered? A pattern, a quiet refusal to look where the truth might live. And yet, in that silence, something else persists, a flicker of curiosity. A sense that the world is wider, stranger, more alive with mystery than we've been taught to believe. We began this journey asking not just what these 10 phenomena are, but why they remain unstudied. Why the very tools built to uncover truth have turned away from the edge. Why the hum is heard but not heeded. Why signals from the deep sea and deep space are archived instead of explored. And perhaps the answer is simple, because truth is not always comfortable. Because the moment we allow these anomalies to be real, we also admit that our models of the world are incomplete. But that is not failure. That is the beginning of science. The real kind. The kind that listens even when the sound is strange. The kind that looks again even when the first glance is confusing. The kind that dares to ask not just, "What is this?" but, "What does this mean?" These mysteries do not beg for belief. They ask for attention. They are not threats to science. They are invitations, reminders that beyond the horizon of certainty lies the vast, thrilling unknown. Perhaps someday the hum will be mapped, the lights will be named, the bloop will have coordinates, and the signal a sender. Until then, they remain as they are, testaments to the unfinished nature of our knowledge. And in that unfinished space, we find our place not as authorities, but as explorers. The unknown is not a failure of understanding. It is the space where wonder lives.